Hello there and welcome to Lower 6th Further Maths AL. This is the core part of the syllabus and we're working on sample assessment material question 2, and this is a vectors question. The first part here is to find the Cartesian form of this equation here. So we have a point on the plane and a perpendicular vector n. So it shouldn't be too hard. We need to recall the equation of a plane that looks like this. r dot n equals a dot n. And this vector here, that's obviously a point on the plane, that's a, little a, and this here is the perpendicular to our vector, so that's going to be the vector n. So all you need to do is substitute these values into your equation, and you're going to get something that looks like this, so a dot with n. Now generally this a dot n that we have at the back here, we're going to simplify this to a value and actually do the dot product on this. So what we're going to do is, to do the dot product, we multiply the x components together, the y components together, and the z components together, and add together their results. So we're going to get 15 plus 3 from the double negative, take away 8, which is going to give us 10. So we get a 10 on the right hand side here. Now for Cartesian form, we want something that looks like 5x plus, we want an equation basically. So what we're going to do here is we're going to replace r with x, y, z. Now x, y and z here are representing points on the plane. So what we can do then is just do the dot product of x, y, z with our vector n here, 3 minus 1, 2. And you can see here, x times x, we'll get 3x, minus 1 times the y, we'll get minus y, and 2 times the z, we're going to get 2z equals 10. Perfect, so that's the Cartesian form of the equation. Okay, so for part B, what we have here is the equation of a line, and we have our plane from before. And it says that line intersects the plane at a point x, show that the acute angle between the plane and the line is 21.2 degrees to the nearest 1 decimal place. So what we need to do here is recall how we find the angle between a line and a vector. Now remember this diagram here. This is what you need to be revising, the diagram. So we have a plane, we have its perpendicular vector here, we have a line coming in to meet that vector, coming in to meet that plane at the point x. Now this is the line L. Now there is no hard and fast method to work out the there's no formula to work out the angle between a line and a plane. However, we can recall the rule that helps us work out the angle between two lines, and that is simply a dot b equals mod A mod B cos theta. So what we're instead going to do here is work out the angle between the two lines here, the perpendicular vector and the line, and then we're just going to do 90 minus it because n is perpendicular to the plane. So it's just going to be then theta equals 90 minus alpha, and we'll get our answer. So what we need to do now is substitute our a's and b's into the formula here. So I'll start with using a as the vector n, so that's going to be 3 minus 1, 2. We were told that in the question part before. And we need to dot this with b, and b will represent the line L. So the line L is going to have a direction vector of this part here. Remember, in the scalar product rule, we only use the direction vectors to dot with or to modulus because that's the angle at which it's hitting the plane and the coordinate x. So it's going to be then minus 1, minus 5, 3. And then on the other side, it's the mod of a, which is the Pythagoras distance of the vector. So 3 squared, add 1 squared, add 2 squared, times by the modulus of b, which is going to be 1 squared, add 5 squared, add 3 squared, and then we times by cos of alpha. So doing the dot product like we did before, x times x gives us -3 plus the 5 and plus the 6 as well. And the square roots of these vectors are going to be 14 and 35. And this is going to be cos alpha. Now what we want to do is get cos alpha on its own and then do the inverse cos. So here we're going to get 11, take away 3, we're going to get an 8. And divide through by those moduluses, we'll get square root of 14, square root of 35. And what we're going to do is we're going to do cos -1 of this answer here. And we're therefore going to get 68.8 degrees. So therefore, this is equal to alpha. So therefore the angle between the line and the plane is therefore going to be theta equals 90 minus 68.8, which is going to be 21.2. Okay, so as I say, this part here is what you need to be revising the diagram and knowing that when you find the angle between a line and a plane, you need to find the angle between the two lines and then just do a 90 minus it. Okay, so that's part B done. Part C is find the point x, so find the coordinate at which the two plane and the line meet. So the coordinate x for now, we'll give it a vector of, it's going to be somewhere along this line, so we'll give it a vector of 7 minus lambda, 3 minus 5 lambda, and -2 plus 3 lambda. Alright, so this is the point along our line, and as lambda changes, the coordinate changes, but we want to find the exact value of lambda such that we can locate where x is. Now this here is our x coordinate, this here is our y coordinate, and this here is our z coordinate. And what we have to do now is we're going to substitute in to the equation of the plane here our x coordinate and our y coordinate and our z coordinate. So we're going to get 3 lots of 7 minus lambda, which is 21 minus 3 lambda. Take away the y coordinates, that we take away the 3 and we'll add on the 5 lambda for the double negative, and then it will be double of the z coordinate, so -4 plus 6 lambda, and that's going to equal 10. So grouping all of our lambdas together first, we're going to get 8 lambda equals 10, take away the 21, we'll get -11, add on the 3, we'll get -8, and add on the 4, and we're going to get -4. So here lambda equals -1/2. So all that's left for us to do now is bring back in this coordinate x here, but lambda equals -1/2. So we're going to get here 7.5 from the double negative and -1/2 and taking away the lambda. -5/2, so that's 2.5 added on, so that would be 5.5. And for the last part here, it's going to be add on 3 halves, or take away 3 halves, sorry. So that would be -1.5. We've already got -2, so it would be -3.5. Perfect. So this coordinate here is our coordinate x, where the line and the plane meet. So all I've done is effectively substituted the equations of the lines, or the coordinates of the lines, into the equation of the plane, worked out lambda, and then worked out where my coordinate is along the line. Great, that's 10 marks for that question. Thanks for watching.